Let's see this one. Just testing this out. Okay. Yeah, this Mantissa, I don't see yet why. So this Mantissa, it's just kind of like a big number. This is like a big positive number when you just interpret it like this. I don't know, if we're just like interpreting it as like a big like unsigned number, this is saying that we should shift it down 23. Would that make sense to like shift something down like divided by 10? Like if we had 500 and we said let's divide it by 10 to the 2, yeah, we would just like chop off these 2 zeros and this would be 5. Oh, but what if we went more? If we did like 10 to the 3, then we're really just moving the decimal place 1, 2, 3 like this. And like that's what we come up with. It's just like the decimal thing. So just like here, the Mantissa is just like a big unsigned number, like 5 billion, quadrillion, whatever. And we basically just move the decimal place 23 times to the left. And then we wind up with basically this number here. That's interesting. Okay. So this thing divided by 2 to the 23rd, what that does is that puts a decimal place here. What does that actually do like in the computer though? I mean, it's effectively doing that. And then we just like add this one. We just add this one thing here in front. And then we multiply it by the exponent. How do we actually, I guess there's like a, I mean, if I just had like, if I just had like a float, I guess, like on the computer, like I just had like 500 and then I just said, hey, divided by, I don't know, this seems circular because like I'm already thinking of storing this 500 in like in a float. So I'm just saying, oh, divide it by 10 to the 4th. And, you know, it just does this. And, you know, like you can represent this. But like this already is a float. To like do this division, it's like you're doing it on a float. I don't understand. I understand what it means to do division on like a short where, you know, it's just like this, and you say this thing divided by 2 to the 3rd. That just shifts these like 3 to the right. So it'll like chop off this, it'll chop off this, it'll chop off this, and it'll just give you 10001 effectively. It's like, you know, 3 zeros in front. That's kind of, so it makes sense to kind of like chop off these zeros, but what does it mean when you have an int to like go, it's almost like you divide this again, this is like integer division, and it just like truncates it and gives you 0, and then you just have like zeros left. I don't see what it means to do 2 to the 23rd like that on a friggin' int. But I understand it conceptually. This is some CPU operation or something where you just give it the Mantissa and you give it the exponent, and it'll do what? Like, what will it give you? It'll just give you friggin' back this shit. like it's just going to give you back another floating point number. So you actually have to implement like plus and subtraction and multiplication and division on floating point numbers. Like how would you add two numbers in scientific notation? 1.057 times 10 to the 6th plus 2.2 times 10 to the negative 3rd. Like, how would you actually do that? You need to basically operate on like the exponents and the mantissas. But, you know, this like 1.057 is kind of like in the actual kind of like number thing, it's kind of like up here. And then this 2.2, it's like way down here. And you kind of like add these two up. You know, do you kind of like convert to this like naive intermediate representation and do the addition and then like do it back to scientific notation, the IEEE, you know, notation, or do you just like do it in this? It's almost like you have, yeah. So anyway, I think that's a good demo.